Hey guys, in this video I'm going to review the sum and difference identities, or examples using them. So before school shut down, the last thing we did was sum and difference identities. Remember, you're allowed to have a little note card that has each of those on it, so if you haven't made a note card, I would do that. And I'm going to review two types of problems. So the first one, I'm going to just do tangent. So if you have a problem like tangent of pi over 12. So the reason the sum and difference identities are so great are because pi over 12 is not on the unit circle. So if we know two angles that add to pi over 12, then we can use the sum and difference identities to figure out tangent of pi over 12. So that's probably the hardest part, is trying to figure out two angles that add or subtract to be pi over 12, especially radians. And that really is just going to be trial and error. You on like a little scrap section can practice figuring out a couple. For this one, the two angles I used are pi over 3 and, minus pi over 4. With tangent, a trick is to try to use pi over 4 and pi over 3 whenever you can, or really any angle on the unit circle that has a reference angle of pi over 4 or pi over 3. That way, you get nice numbers. So remember, tangent of pi over 3 is root 3, whereas if you use pi over 6 in a different angle, then you're going to end up with a fraction and a fraction, and that just makes it challenging. So now that I have my two angles, I'm going to use my difference identity. So the difference identity states that tangent of your first angle, which is pi over 3, minus tangent of your second angle, which is pi over 4. It's not negative pi over 4. All divided by 1 plus tangent of your first angle, pi over 3, times tangent of your second angle. And again, you get the identities, so just use your note card or look at them. Now I'm going to use my unit circle. So as I said earlier, tangent of pi over 3 is root 3, and tangent of pi over 4 is 1. So then I have 1 plus the square root of 3, because this is just square root of 3 times 1. Okay, and then what we want to do next is rationalize the denominator. So I'm going to multiply by 1 minus the square root of 3 over 1 minus the square root of 3. And remember, the whole reason we're doing this, we're technically multiplying by 1. And we want to use a different sign. So because it's 1 plus in the denominator, we're going to use 1 minus, the conjugate, so that the radical will go away. So now we just FOIL. So square root of 3 times 1. Square root of 3 times the negative square root of 3 will be the negative square root of 9, which is negative 3. Negative 1 times 1. And then negative 1 times negative square root of 3. And then in my denominator, 1 times 1 is 1. And then I'm going to show this step because we might be a little rusty, but you don't have to. So remember, this is going to be negative root 3 and then positive root 3, which we usually skip that step, but sometimes students, here I'll even write that step in. Sometimes students accidentally do plus instead, and that's not going to cancel it. It has to be the conjugate. Anyways, so at this point, I'm going to combine like terms and simplify. So in my numerator, I've got negative 4 and 2 root 3. Remember, adding radicals is like adding x's. And then I'm going to have 1, I guess I'll show it, 1 minus 3. Which is negative 2. And now I can simplify. So negative 4 divided by negative 2 is 2. 2 divided by negative 2 is negative 1. So that is my final answer. So tangent is a bit more work, but the hardest, or in my opinion, the hardest part is just getting these two angles that are going to add or subtract. So sine and cosine are also very similar, and I believe that degrees are a little bit easier for you guys. One thing I'd like to review, well, not review, we didn't do this in class, but it is on the worksheet. It's a challenging problem, but it really isn't that much harder, is cosecant. To make it a little bit easier, I'm going to do, this is straight from that worksheet I assigned at the beginning of this week. I'm going to do cosecant of 915 degrees. So first thing, the way I like to think about this problem is, well, cosecant, we don't have an identity for cosecant, so let's think about it in terms of sine. So this is the same as 1 over sine of 915 degrees. So what I did is I was like, you know what? I'm not even going to think about a fraction right now. I'm just going to do a different problem. I'm going to do sine of 915. And then when I'm done, I'll divide it and get cosecant. Then what I was thinking is like, you know, 915, that's such a big number. And then remember the unit circle, there's coterminal angles. So what I did is I was like, well, what is a coterminal angle to 915 degrees? That's on, or between 0 and 360. So I took 915 and subtracted 360. I believe we have to do it a couple times. And so that means that sine of 915 degrees is actually the same as 195 degrees. They're going to be in the exact same spot. So after figuring that out, it's a lot easier to think of two numbers that are on the unit circle. And I went with 150 degrees plus 45 degrees. And remember, your two angles don't have to be the exact same as mine. They just have to both be on the unit circle and either add or subtract to that same angle. So now I'm going to use my sum identity. So that's going to be sine of the first angle times cosine of the second angle plus cosine of the first angle times sine of the second angle. Using my unit circle, sine of 150 is positive 1/2. And cosine of 45 is positive root 2 over 2. Cosine of 150 is going to be negative root 3 over 2. And sine of 45 is positive root 2 over 2. So now I'm going to multiply. So we get the square root of 2 over 4 minus the square root of 6 over 4, which I could just rewrite that with one denominator. Okay, so remember, that's what sine of 915 is, but I want cosecant. So cosecant, so this is sine of 915. I want cosecant. So I know that it's going to be equal to 1 over this whole thing, which ends up just being the reciprocal. And now I just need to simplify. So I'm going to multiply by the conjugate to rationalize the denominator. So we have 4 times the square root of 2 plus 4 times the square root of 6. And then I get the square root of 4 minus the square root of 36. Oops. Numerator stays the same. Denominator, I get 2 minus 6, which is negative 4. And then I'm going to simplify. So I'm left with negative square root of 2 minus the square root of 6. And that is what cosecant of 915 degrees is. So I hope this video helps clear it up. If it doesn't, then check the calendar and come to one of the Zoom flex times.